Welcome to Chapter 1 from Soil Science and Management. We're going to discuss today the importance of soil. Namely, we're going to explain the importance of soil in plant growth, soil quality, and we're going to discuss how soil is being used in climate change and other roles soil plays. So many of the early civilizations learned that having good soil quality was important to have good plant growth. This can be seen way back to the Chinese when they were developing croplands in the floodplains of the Yellow River. Many of the rivers in the Middle East were utilized because areas away from the rivers were not able to sustain plant growth. Um, if you look to rivers and deltas of rivers, those are considered some of the richest and best soils for growing. And one of the really great examples of that is here in California. The California Bay Delta allows California to have a strong economy, gives them additional growing mediums. Many different crops are grown there. Things that you could not grow, other areas of California are able to thrive there because of the quality of the soil there in the Delta. So it's been a great addition to California's economy, and it has been utilized in providing those crops for not only California but the whole of the United States. So basically, when we think of soil, it's a life-supporting layer of material. There are different parts of the soil, but it is utilized by both plants and animals. Um, Typically, we think of soil as the medium for plant growth, and you need to have four things that are very important to plants, and these are the four things that plants depend on soil for. And I'm going to give you a hint that this is going to be something that comes up often in the class. Is these four key elements of the soil is number one, anchorage, and this is to hold plants in place. Plants hold themselves in place, and also plants can hold the soil in place by utilizing their roots in erosion control and utilizing the roots to hold the plant in place so that it can grow tall and strong. You wouldn't have trees the way they look today if they didn't have proper soil and proper anchorage in the soil. So that is a very important thing. Uh, all water that passes through to a plant is passed through the root system, so it all has to come through the soils. Uh, also, oxygen is uptaked through the roots of the plants, and all nutrients are moved through the soil into the plants. So without soil, we would have no plants. If you've ever tried to grow a plant in poor soil, you've noticed that the plant doesn't grow. If you've ever transplanted into an area, the plant will typically die. So soil is very important, and to have a correct balance in the soil is very important for plant growth. So when we look at soil, we think of it as a three-phase system. You have the solid particles, you have the pore spaces, and you have the liquids. So now the solid particles, those are any number of things. You have your sands, your silts, your clays, and those are the actual structure of the soil, the things that hold it together. The pore spaces, and we're going to get into this a little more deeply later on in the class, but you have both micro and macro pores. Now, they're exactly as they sound. A micropore is a very small pore. It's typically does not hold, like, say, liquids. It holds more air. It holds nutrients. But the macropores, those are what holds oxygen and the liquids so that the plants have access to them. When we look at root growth, uh, you have to have enough soil there so that the plants can grow. So if you have, say, a new soil with not a lot of topsoil or not a lot of room until bedrock, it's very hard for plants to grow in this. I dealt with a project down in Pomona, and I think they had like 4 inches of soil, and the roots were literally growing sideways once you hit the bedrock area. So you had 4 inches of soil, plants had roots. This is a soccer field, and the grass would grow down the 4 inches, and it would go sideways, and it was not creating a great system for the area. So when we look at soil, agricultural uses are definitely one of the most common things. Uh, when you think of horticulture, not everybody thinks about agriculture as being, horticulturally driven, but if we didn't have agriculture, we wouldn't have horticulture. So we all started with typically grazing lands, and before humans became gatherers or settled down, we had cattle that we had, and so we had to have the proper food for those cattle. And then we started taking those grazing lands and turning them into croplands, and then ultimately we started turning in the cropland into housing and areas where we could grow, have horticulture take over things. When we look at non-agricultural uses, there's recreation, so we go off-roading, engineering. We have to build stuff on soil, and we have to make sure that that soil is structurally sound. Uh, in waste disposal, there are certain areas that you cannot put landfills, for example, because of soil structure, soil type, water table in the soil. There are many different things that you have to take into account when it comes to non-agricultural or non-plant bearing uses. Lastly would be building materials. So all the different things that we think about when you are, say, talking about concrete. We have to put sand, or if we're talking about asphalt, we have rocks and sand and asphalt that we have to utilize a high quality of this material. And so those are other areas that we're not typically thinking about, but soil is very important, and understanding soil physics and soil mechanics is extremely important in these areas. When we look at the land uses in the United States, approximately 80% of all the land is utilized for crops or forest or rangeland, and this is not even including the National Park Service lands or any of the other federal protected lands such as forests and BLM type lands. And then one of the probably most important things that we're going to talk about in this class is soil quality. And yes, it is definitely called soil health. And some of the things that can cause bad soil quality is erosion or pollution. If we're having people, for example, they want to dump chemicals into the ground, it can actually change the soil chemistry, so you can never grow things there again. Somebody who changes their oil in their car, for example, and decides that it's a good idea to dump the oil on the ground in a certain spot, can actually sterilize the soil for several years, because uh, the soil particles will hold on to portions of that oil or other contaminants, and won't let uh, uh, the plants grow there. The plants will be just unhappy and won't want to grow in those areas. So something we're going to talk about a lot are something called BMPs, or best management practices. And these are kind of an industry term to understand what is recommended when you're dealing with certain problems. Often we are having, say, soil quality or water quality issues, and we have to look to what the best management practice is for that specific item when we are talking about it, and then we'll come up with the best solution for those problems. And so these best management practices offer the best and most practical and usually the most cost-effective way to solve a problem that we may be facing in anything. But in this example, we're talking about dealing with, say, soil quality. So soil does play a critical role in natural ecosystems, and if you actually were to look at the soil underneath many of the forests that inhabit the earth, there's actually sort of a network of things that are happening under there. This is, different funguses and different, water tables or pockets of nutrients, and all of these different things are utilized by the soil and by the plants to create a healthy natural ecosystem. If you take any one part of that out of the system, then you start to lose things and you don't end up with the same strong soil and the same strong, healthy plants. So, one of the big things that we're going to talk about is some of the different gas cycles. So, the nitrification cycle, there is a ammonification cycle, and then we're going to touch on how soil can be used and how it affects climate change. Whatever your opinion on climate change is, there are gases that are out there that are creating, that are called greenhouse gases, and actually soil can be uh, used to decrease them, but there's also instances where soils will be increasing these greenhouse gases and could cause issues for how many are in the air in certain areas, and thus uh, contributing to the detriment of climate change. When we think about the soil and the climate, we think about organic matter in the soil being one of the planet's largest reservoirs of carbon. And we all are full of carbon. So, everybody says, well, you're 60% water, but you do the rest like of you is around 30% carbon. So most of us are water and carbon. And carbon is not necessarily a bad thing. CO2 is not necessarily a bad thing. Uh, Obviously, we have to be conscious of what we're doing, and we have to understand how this process works, and we have to be good actors, and we have to make sure that we're not um, um, polluting. But when we think about carbon dioxide, it is actually a very important thing, and how the soil can interact with this exchange is we do have plants that grow, and those plants do require CO2. So uh, many times people don't realize those forests, those grass areas, those plant areas, those are actually exchanging a lot of that CO2, and they're taking that carbon and they're giving it somewhere to go. So when we have a plant that has a ton of new growth, that's a lot of carbon that's being built into that plant and that's being taken out of the atmosphere. So plants can do wonders for climate change and can actually reduce this. And a lot of this organic matter is taken into the fields, and yes, it can be off-gassed into the atmosphere uh, because of these gas exchanges, but this is a very small portion of the climate change model or the greenhouse gas model. So, in summary, this has been kind of a short lecture. There's not a lot here, but the big takeaways are soil functions. Um, the soil serves to support life, plants, and then in turn animals. You can't have the animals if you don't have the plant eaters, and then you don't have the meat eaters if you don't have the plant eaters. So it is part of the greater food chain, food web. Um, Again, please remember that there are the four main purposes for soil. That's going to be your anchorage, water movement, nutrient movement, and then again oxygen movement to the plant. We're going to get more in depth into those portions of this so that that those points are driven home pretty heavily. And then people, we interact with soil every day, whether you think it or not. You may not touch the soil. You could walk on concrete all day long, but you know what? You're still interacting with soil. You go to McDonald's, eat a hamburger, and that cow, hey, you walked on soil. That cow ate the grass that was grown in the soil, and in turn, he was turned into your hamburger. So everything that we do has some portion of interaction with soil. in our daily lives, we are doing something. Everything has to do with soil. Even the computer you're watching this on, all the components came from somewhere in the soil or in the earth, and it has now been converted into something that you can use to listen to me talk to you. So thank you for joining me for chapter 1. I hope the lecture was great, and I will be getting to chapter 2 next.